So welcome guys to part 2 of our series where we'll continue with the analysis process of our WannaCry variant. Remember, in this series we are analyzing the original variant, and what we noticed from PE Studio is that this variant is using a PKZip signature. And just to show you guys some of the strings that we extracted, use Notepad. So this is our variant, and ED strings is the strings that we extracted from this variant. So we'll use Notepad to extract the strings and check them. Then from the strings, we'll search for WannaCry. So the string that we're specifically looking for is this specific string. And if you remember, guys, we also saw this string on IDA while we were trying to analyze some of the import modules that were called by the DLL files. And this was one of the strings that we noticed. So since this variant is using a PKZip signature, then we'll try and uncompress this specific variant. And the compression password that we use is this specific password. So let's try and uncompress, then we see if it will request for a password to try and unpack some of the files from this variant. So in order to uncompress, we use 7-zip. And we'll try and extract the files here. And as you can see, this specific variant is requesting a password. So we'll try with this specific string that we found. Just to show you guys, we're using the same string. Click OK. So it seems the password works. And if you check this specific folder, we can see some of the binary files and the executable files that we noticed in our strings as part of this malware variant. So right now we've already uncompressed and extracted the files that are zipped within this specific variant. And what we'll do is we'll try and check and analyze some of these files. So I typically use hex editor to view the ANSI code corresponding values of the offset values of this file. We'll open hex editor. Then we'll drag our file to hex editor. Let's start with the c.wncry. So we can see the contents of this specific file. And first things first, we have a suspicious onion address over here. So this might be a C2 beacon or an anonymous link that this variant is using to communicate. And from what we know, onion sites are normally used in dark web websites to hide traffic using the Tor network. For those of you guys who don't know the dark web, I'll introduce another new series where I'll cover how the dark web works and how threat actors normally use the dark web to communicate safely and anonymously. So right off the bat, we can see we have a couple of URLs from this specific file. And the first URL is an onion address. And we have a second URL. So if you notice from the URL, it's coming from the Tor distribution website. And the CTube icon is most likely using the onion address for anonymity. So we'll switch back and analyze our second file, which is the r.wnry file. And from the decoded text, which is the ANSI corresponding value of the offset characters, we can see that we have a message over here. And what you notice is in this message is this specific decoded text is what appears in the dialog box after your machine is infected with the ransomware variant. So we'll check some of this information in our dynamic analysis phase, which is coming up next. And as you can see, we have a prompt over here, and it gives you an option to decrypt the files once you pay the ransom. So this file, safe to say that it's being used to display the message on the dialog box once your machine is infected with the ransomware variant. We'll switch to a third analysis and we'll check some of the other files. So let's load s.wnry. And this time, if you check the first two offset values, 54B, and it has a corresponding decoded text of PK, which means that this specific file is most likely also using a PK-zip signature. And if we try and check some of the decoded text, you can see most of it is encrypted and written in gibberish. So right now we have one file that has some of the URLs, which are some of the onion addresses that this variant is trying to communicate with. For the second file, we saw that it displays that specific message that is shown on the dialog box once your machine is infected with this variant. And for this file, it has a PK-zip signature due to the corresponding decoded text of the first 2 bytes of the offset values, which is PK. And you also see a mention of TOR, but the rest of the data is gibberish. We'll continue and open the other file. So for this file, it has the signature WannaCry, and the rest of the content is encrypted. So the signature WannaCry is most likely used when most of the files are encrypted and the file extension is changed. And it will use the particular WannaCry signature to encrypt most of the files. Then finally, we have the last file. Now for the last file, you can see that the first 2 offset values are 4D5A. And if you remember, guys, files that have the first two bytes of the offset values 4D5A and the corresponding decoded text of MZ means that this specific file is a process executable. And when you extracted it from this specific variant, it is saved as a binary file with no extension of an exe. So we already know that this specific file is a process executable. Another hint is this specific decoded text that displays this program cannot be run in DOS mode. The other contents are most likely encrypted. but we for sure know that this specific file is a process executable. Maybe if we scroll down, you can see that there's a mention of specific tasks. So in this case, we have the task hsvc.exe, checks for memory, valid distance. Most of the data is encrypted, but we can see some of the suspicious imports that we had before. So we've already discussed some of these imports from our analysis. And as you can see over here, this file most likely is an executable that caused most of the suspicious imports that we had from the defined libraries that are built in within this specific variant. So before we execute our malware sample, what we do is we'll capture a registry key using Regshot. And what we'll do is we'll compare both registry keys before the machine is infected and after the machine is infected. So in order to capture the registry keys and compare the values, we'll utilize a tool called Regshot. So Regshot is a tool designed to capture all the registry keys and all the registry values. And what we'll do is we'll capture the registry keys using a plain txt log. And in order to capture the first shot, which includes a first snapshot of our registry keys, you click first shot so that you can capture all the keys. So we're going to capture our first registry keys. Then after that, we'll execute our malware variant, which is the WannaCry original variant, denoted by the SHA-256 value of ED01 and so forth. Then we'll compare and see some of the registry key values that are modified, added, and deleted. So let's start by capturing our first shot. So we'll only capture a shot and we'll skip the process where we're going to save the file, because after we execute our variant, then most likely this file will be corrupted. So we'll only capture a shot without saving any file. So click shot, and we'll give it some time to capture all the registry keys and the values. So as you can see, we have around 512,395 keys that were captured and over 800,000 registry key values that were captured. So we'll execute our variant. Remember, we've already changed the extension to an exe. We've unpacked some of the files that were hidden within this variant using the encryption key that was saved in our strings file. And we've already analyzed most of these files. So what we'll do is we'll execute our variant. In most typical cases, hackers normally deploy various techniques to execute malware variants automatically. But in our case, since we're only doing a demonstration, we'll execute a malware variant manually. So in order to execute a malware variant, we'll run this specific variant with admin privileges. So just to confirm, we still have Remnux virtual machine running, and the iNet simulator is simulating most of the malware traffic. We have the IP of our Remnux virtual machine, and we'll try and ping these machines so that we can confirm everything is running fine, and most of the network traffic is simulated. In some cases, when you're trying to analyze WannaCry variant without simulating most of the network traffic, like I did before, you'll notice that this variant won't infect this specific system because it automatically detects if any network is running from this machine. So I've tried it a couple of times before without simulating the traffic, and it doesn't infect the machine. So you'll most likely have to simulate most of the network traffic so that this variant can execute as intended. So as you can see, we have a replay of the bytes data, and what we'll do is we'll run this variant as administrator. Before we do that, I think what we can do is we'll just capture a screenshot so that you can see how this file modifies any saved file once the machine is infected. So you can use a screenshot or any other document. For this one, we just save it within the same directory for analysis. So it's on malware samples, WannaCry, and this is the variant that we're trying to analyze. So we'll label it as image 1. And we'll save the file. So as you can see right now, we have our image 1, we have the variant as the executable, and let's run our variant and see. So automatically what you can see is there are new files that are added over here. We have the WannaDecrypt executable. Most likely this executable runs once you try and open any file that is infected. And we'll see a prompt shortly. We can also see our image over here, and you also have the modified image with the modified extension of wncry, which means it's most likely infected. And let's just give it some time to infect the system. In most cases, it typically takes some minutes before things start changing. But right off the back, you can see that some files have already been added, and some files are already modified. So give it about 1 minute, 1 to 2 minutes, then we'll see a couple of changes. And as you can see over here, our original image is already gone. So the files have modified extensions, and WannaCry is still running and infecting most of our files. And if you try and open one of the files, which has a double extension, you can see it's not possible opening this file. It's most likely infected. So as you can see, guys, our machine is already infected. And desktop wallpaper is already changed, and we have other files over here. And as you can see, we're getting our prompt dialog, and it's giving you a Bitcoin address where you can send the ransom payment so that they can give you the decryption key to open most of the files. So right now, our machine is already infected. What we'll do is capture a second registry shot. So we'll click second shot and click shot. And you'll notice every time that you try and open any file or try and select any value, then this dialog box will automatically pop up. So give our machine some time to capture a second registry shot. And as you can see, our second registry shot is successfully completed. And what we'll do is click OK. Then we'll click compare to compare our first and second registry shots. So we'll do a comparison and output the details that we'll get. So guys, as you can see, we have around 4 registry keys that are deleted. We have around 39 registry keys that were added over here. And what you'll notice is these registry keys that were added are in the specified directory on Windows current version. So this most likely is a method in which this variant is trying to enable persistence by trying to modify the Windows current version Explorer registry key. And so as you can see, guys, we have registry keys that were added. And if we scroll down, we can check the sum of the values that were added as well. And as you can see, it's in the same registry keys on Windows current version. And most likely this is a persistent mechanism where this variant automatically executes when the machine runs on startup. So we're going to analyze our registry keys using a reg editor just to confirm that some of the registry key values were added. So we'll check the H key local machine, then on software, And there's a specific registry node called wow6432 node. So this is a very new registry node that was added. And as you can see over here, we have our WannaCry registry key. So like I said before, this variant modifies the registry keys, and as you can see, we have WannaCry registry key that was added when we executed our variant. So we have around 168 values added. Some of it is encrypted. In fact, most of the values over here are encrypted. So it not only creates new registry keys, but it creates also the values in the registry keys. And some of the values are already encrypted. And we've seen that it uses a persistent mechanism where the Windows current version registry key is modified to enable persistence. So that's it for registry key analysis. We've seen that some of the registry keys that were deleted over here, including the group policy keys, and we also have some registry keys that were added. And one of the registry keys that we've identified from the HKLM software directory is that we have a new registry key that is created called WannaCry. So we've seen that this specific variant modifies some of the registry keys. We've checked and seen some of the registry values that are added to the Windows current key version. We see now this variant tries to modify some of these registry keys to enable persistence, and we've already seen all the keys that were added from our Regshot capture. So the next step is to try and analyze all the running processes that are in our system once we execute the variant. And as you can see, we have both images, modified extensions to the wncry, which is our WannaCry variant extension. And we'll use process monitor to analyze all the processes, check some of the child processes, and see some of the executables that are called by this variant. So we'll navigate to tools and we'll check the process tree so that we can get this breakdown of the processes. And ideally, what we're trying to look at is our executable denoted by a SHA-256 value ED01. So looking for executable ED01, just scroll down. So these are executable over here. So let me just expand this page so you guys can see it. So we have our ED01, and the first executable that is called is the attribute.exe. So in most cases, the attribute.exe is an executable that is responsible for modifying file attributes. And in this case, this variant is trying to modify file attributes by hiding and changing specific attributes of a file. So in most cases, you'll see malwares deploying this type of utility to manipulate and change file properties for encryption. The second executable that we can see over here, that is the conhost.exe. and it's denoted by the process ID 6324. So all these numbers are process IDs that are related to these specific processes. So for the conhost.exe, this is the Windows console host process that it normally runs in a Windows environment, and it provides an interface for console applications to interact with the user. So in our case, this variant is using the conhost.exe to display some of the console-based messages once we execute the commands. The next executable that we have is the icalcs.exe. So icalcs modifies file and folder permissions in Windows. And like we said before, WannaCry variant is a variant that tries to modify files and adds extensions to different files. And we can see in this case that once the malware accesses this specific executable, then it will manipulate some of the access control settings. It will grant and revoke permissions on specific files, directories, and paths as part of the encryption process. So we have the tasksche.exe that is responsible for the cleanup process, and as you can see, the lifetime is a very short lifetime. So we have the green bars over here that denote the lifetime of this specific variant. So once the malware executes, then it will launch the tasksche.exe to clear up any footprints that may be left available in the system. So we've talked about the cmd.exe, and cmd, as you obviously know, is the Windows command prompt, and it provides a command line interface for executing various commands and scripts that are called by this specific variant. So from the cmd, it also launches the conhost. We've already discussed what conhost does. And it will also execute another executable called cscript.exe. So the cscript.exe is a command line scripting that is used to execute scripts that are written in VBScript or JScript. The malware in this case employs the cscript.exe to run malicious scripts such as encryption, communication, and also performing other malicious activities. If we scroll down in some of the processes, we still have the taskdl.exe. Then once all these executables are run, then we have the WannaCry decrypt executable that is denoted as wannadecryptor.exe, and this is the dialog box that pops up once we try and open any file, and it will specifically ask for the ransom payments each and every time we try and open and execute any file. So we have a couple of wannadecryptor executables that are running, and in most cases it will try and ask for the ransom. So remember, we extracted our variant. We saw some of the files that are inbuilt within this specific variant, and we've seen some of the processes, the taskdl and taskse.exe, that are running on the process tree from the original executable ed01. We also have tasksche.exe. So once the WannaCry decrypt executable becomes visible in a process monitor, the tasksche.exe executable emerges, and it's most likely related to network operations. As you can see from the description, it will wait and send a signal over a network. So tasksche.exe serves as a communication component in the decryption process, and its purpose is to verify whether the ransom payment has been made to enable the decryption process. So remember to make the payments form of Bitcoin, you'll need network connection so that these payments can be processed over the internet. So we've seen some of the processes that are executed by this variant. We've seen the process that are called, some of the process trees that we have from this variant, and all the executables that are called. And we've drawn conclusion that the tasksche.exe is responsible for network communications. And in this case, it's responsible for executing network operations if the user wants to pay any ransom to this variant. So the next step will be to try and analyze our traffic. Immediately once the dialog box pops up, then it will try and request for the ransom payments, and we'll capture network traffic on Wireshark and analyze some of the packets and see what we'll get from our traffic capture. So we have Wireshark up and running. We'll run the variant as an administrator. And like I showed you guys, if you remember, we have our INET simulator running on Remnox. So the next step to do is execute a variant and start the capture on Wireshark. Or what you can do is we can start the capture first, then we'll execute a variant so we can get all the traffic. And as you can see, we have a couple of NBS requests. So NBS stands for Net BIOS Name Service Packets. And in this scanning activity of the network analysis, once it tries to extract the Net BIOS name service, then it typically tries and exploits the Windows SMB protocol. And SMB protocol exploit is linked to the EternalBlue exploit that is common in Windows operating system. So I'll give you some time to capture most of the traffic, then we'll start analyzing some of these packet captures. So while we're doing our Wireshark traffic capture, what we'll do is we'll try and pretend to pay the ransom so that we can see the traffic that is coming from this variant. So we'll try and click decrypt. Can check payment. So it will try and connect to the server. And remember, we're capturing packets that are coming from our machine, running on the INET simulated traffic. So while it attempts to resolve the connection, we have traffic capture on Wireshark. So since we are running on a simulated traffic, the connection is incomplete because it's not connected to the actual internet. So what we'll do is just cancel this process, experiment with some of the buttons that are included over here, like contact us. You can send a dummy message. Hi, find files. I will pay ransom. So we'll attempt to try and send and also capture the traffic. So I think right now we have enough traffic capture from our decryptor and our WannaCry executable. So let's start by analyzing some of our Wireshark network traffic. And as you can see, we have a suspicious protocol over here called the NBNS, which stands for Net BIOS Name Service. And it's a key indicator that this variant is propagating through the network using a worm-like propagation technique. And it typically spreads by scanning for the SMB protocol that is running on TCP port 455. When it can't resolve that specific hostname, then it falls back to the NBNS broadcasts that is broadcasted on the UDP packet 137. Then it will flood our Ethernet port because our traffic is running from the Ethernet port with NBNS requests so that it can hunt for any new targets that are within the network. So we'll apply one specific protocol so that we can filter all the traffic that is based on the NBNS protocol that is requested. And the specified port is the TCP port 445. So in order to apply our filter, type NBNS. Then we specify our TCP port, which is 445. And we'll hit enter to apply our filter. And as you can see, guys, we have a massive burst of NBNS requests within very short time frames. We also have randomized host names that do not belong to this specific environment. And we can see that there's a follow-up on SMB connection attempts on port 445 after the NBNS lookup fails. So the destination port is within our inbound host network adapter interface, which falls under our IP 10.0.0.0 under the subnet mask 24. Next, we have traffic that is originating from the SSDP protocol. So if you guys can see over here, let me just close this. We have a couple of traffic that is originating from our SSDP protocol. And this protocol typically runs on UDP port 1900. It's typically used by universal plug and play devices like printers, smart TVs, and different IoT devices. So in normal cases, you'll see a couple of SSDP requests, maybe if your device is connected to an external device. But if you see a flood of SSDP requests from a host machine, then in most cases, this variant is trying to do a device discovery within the network. So it will not only try and discover this device, but it will also try and look for other devices that are connected within this network so that it can infect them as well. So just to apply the filter so that we can confirm there's a flooding of SSDP requests, we'll apply a filter on the UDP port 1900. And as you can see, guys, we have a couple of SSDP requests to the destination IP address 239.255.255 to 50. And this likely means that there's a typical flooding of SSDP requests so that this variant can try and detect other universal peripheral devices that are connected to. So this completes our analysis of the Wireshark traffic capture. We've seen some of the protocols that this variant calls and some of the flooding techniques that are used. We've seen now WannaCry exploits the SMB service that is running on TCP port 445 by sending a flood of NBNS packets. We've also seen how it tries and propagates through the network and also discover other universal plugin devices using the SSDP protocol. And in similar case, it will also send flooded packets. We've checked some of the processes that are called by our variant and seen how it enables persistence by trying to modify the registry keys. We've seen how it communicates using some of the processes that are inbuilt within the file. We've checked some of the basic file properties of this malware variant through static analysis. We've dissected the code, and this completes our analysis for the original WannaCry 1.0 variant. So stay tuned, guys. I'll drop a new video soon where we'll cover the analysis with the latter version of WannaCry. If you like this video, uh, please drop a like and subscribe for more content. And I'll see you guys in the next one.